Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Nur Atika binti Lutfi from Maritime Technology program. Today I would like to present about 4 method non-destructive testing. What is non-destructive testing? Non-destructive testing is the process of inspecting, testing or evaluating materials, components for assembly for discontinuous and differences in characteristic without destroying the serviceability of the part of system. In other words, when the inspection or test is completed, the part can still be used. In contrast, the non-destructive testing are destructive in nature and therefore done on a limited number of samples rather than one materials, component or assembly actually being put into service. These destructive testing are often used to determine the physical properties of materials such as impact resistance, ductility, yield and ultimate tensile strength, fracture toughness and fatigue strength, but discontinuous and different in materials. Characteristics are more effective found by non-destructive testing. Today, modern destructive testing are used in manufacturing, fabrication, and in-service inspection to ensure product integrity and reliability, to control manufacturing process, lower production costs, to maintain a uniform quality level during construction. Non-destructive testing used to ensure the quality of materials are joining processes during the fabrication and erection phases in service. Non-destructive testing inspection are used to ensure that products in use continue to have the integrity necessary to ensure their usefulness and their safety of the public. Okay, we start with first method. It is dye penetration testing. Principle of dye penetration testing. Dye penetration tests work on the philosophy of capillary action. A liquid with low surface tension can penetrate into a clean and dry surface if the liquid is kept for a certain time called dwell time. Second, liquid penetrant has to be applied over the test specimen object by dipping, spraying or brushing. The excess amount has to be removed after the dwell time is over. A developer is applied sometimes to maintain future of the developer in to draw the penetrant out of the flow, making an invisible indication visible to the inspector. Depending on the type of dye used, the dye penetration inspection is performed under white or ultraviolet light. This is working procedure. Okay, we start with penetrant application. Next, the liquid penetrant is applied on specimen surface and allowed to soak into flow for a dwell time generally to 10 to 16 minutes. 60 minutes. The dwell time varies depending on the used penetrant viscosity, longer duration for high viscosity, test material and the defect size. Smaller flow size required longer penetration time. Dwell time is normally provided by the penetrants manufacturers and depend on the following. First, the surface tension. Second, the atmosphere and capillary pressure of the defect opening. Third, the pressure of the interpret gas in the flow by the penetrant. And fourth is the radius of the defect. Second working procedure is excess penetrant removal. The excess penetrant need to remove from the sample surface depending on the dye penetrant type. The removal method is select from water washable, solvent removal, lipophilic post-emulsifier and hydrophilic post-emulsifiable. Emulsifiers are used for the highest sensitive level and is chemically react with the oily penetrants, thus making it easier to remove using spray water. Third method is developer. Developer are available in 6 forms. First, dry powder. Second, water soluble. Third, water suspendable. Fourth, non-aqueous type fluorescence. Non-aqueous second, visible dye, and the last is special application. Fourth method is inspection. It using adequate light. Inspection is done using visible light for visible dye penetrant and ultraviolet radiation of adequate intensity for fluorescence penetrant examination. To understand the proper characteristic of defect and the inspector must be experienced enough. The advantage of dye penetrance is small defect can be detected easily, suitable for a range of materials. Inspection is quiet and can easily cover large area and volume. Then the disadvantage is limited to the only surface breaking defect. Material with a non-porous surface are suitable. Direct access to the test surface is a required. Sensitive can be affected by the surface finish and roughness of the body. This is the example of application in sheet repair. We can see we use it at the knuckle of the stainless steel, so we can use this in our sheet. Second method of non-destructive testing is magnetic particle testing. Principle of magnetic particles testing: when high level of magnetic flux are applied to ferromagnetic materials, surface breaking or low subsurface discontinuous will create leak of field. This leak field attract magnetic particles, which is actually finely divided magnetic to themselves, leading to the formation of an indication substrate. Working procedure: first, scope. Second, application reference document. Third, personnel qualification. Fourth, equipment and accessories description. 5, service preparation. 6, technique to be used. 7, detailed step in inspection process. 8, evaluation in indication. 9, preparation of inspection report. 10, cleaning and demagnetization. 11 is application of service protective material is necessary. The advantage is inexpensive equipment, low skill level, quick instant result. Hot testing can be used in the dark. Disadvantage is only magnetic materials may need to demagnetize component. Access may be a problem for the yoke. Need power if using a yoke. No permanent record. Example of application in sheet repair is surface defect, welded joint, and can be used in component of pressure system, boiler, pressure vessel, locomotive, and tank. Third method is radiographic testing. Principle of radiographic testing is the part to be tested is placed between the radiation source and a piece of sensitive film or detector. Only the X-ray or gamma ray radiation is started. The test part will handle some of the radiation by its material density and thickness. Thicker and more dense material will allow less radiation to pass through the specimen, the film specimen, by studying the radiograph data. Defect in parent matter reduce its density and hence they transmit radiation much better than the sound matter. Hence, the radiograph film appear to be darker and the area exposed by the defect. And in radiographic testing, defects are detected using thickness variation. So, larger the variation, the easier the defect is to detect. But when the path of ray is not parallel to a crack, the thickness variation is less and those cracks may not be visible. Then that why it is always suggested to perform radiographic testing by sending ray at variation angle. Procedure: first, surface preparation. Second, selecting the right radiation source and radiographic film. Third, selection of penetrometer for radiographic testing technique. 5. Defect inspecting and removal. 6. Record. All data need to be recorded. That is advantage of radiographic testing. Assembly component can be easy inspected. Surface preparation required in minimal. Both surface and subsurface flow can be detected. Disadvantage is costly affair, slow process and two-sided access of component required. Example of application in sheet repair. First, computed radiography has wide application in correction, detect and measurement. Second is wall thickness measurement can use at wall of sheet. Third is valve inspection we can use to check the seat retention bolt. 4 is to see detail inside the vessel. The fourth method is ultrasonic testing. Principle of ultrasonic testing. We can see like the show at the right, a probe sends a sound wave into a test materials. There are two indications. One from the initial pulse of the probe and the second to the backward echo. As shown in figure, detect cracks are third indication and simultaneously reduce the amplitude of the wall. The backward indication, the depth of the defect is determined by radiation. Working procedure: first, reflection method. That transducer perform both the sending and the receiving the pulse wave as the sound is reflected back to the device. Reflected ultrasound comes from an interface such as back wall of the object or from an imperfection within the object. The diagnostic machine display this result in the form of signal with an amplitude representing the intensity of the reflection and the distance representing the arrival time of the reflection. Second is an attenuation method. This is a transmitter send ultrasound through a one surface and separate receiver detect the amount that has reached in another surface after traveling through the medium. Advantage of ultrasonic testing: high penetrating power which allows the detecting of flow deep in part, high sensitivity permitting the detection of extremely small flow, In many cases, only one surface need to be accessible. This advantage of ultrasonic, but they are irregularly in shape, very small or thin, and not homogeneous. Inspected item must be water resistant when using water-based compounds that do not contain rust inhibitor. In this case, antifreeze liquid with inhibitor are often used. Example of application in ship marine non-destructive testing such as ultrasonic hull inspection improve technician abilities to detect the deterioration, damage or defect. Ultrasonic testing allows ship owner to more effective know about correction and measure hull thickness than visual inspection. This is the references that you can use to see the four methods. So that's all from me. Thank you.